All right, so enough talking. Let's get down to business. Let's get started with allocation mechanism. So allocation mechanism is the automated mechanism, and this is the automated part of non-financial incentives. It's going to be it is enforced with rules, algorithms, code, your ones and zeros, and we're going to look at reputation as well as fair allocation. So in allocation mechanism, I'm going to share a case study with you, two examples, and then we're going to move on to the voting protocol. But in allocation mechanism, this is just two smaller variables or factors to consider, and there are a lot more things you can add to allocation mechanism. It's not an exhaustive list. So the first thing is reputation. So one way to reduce or to mitigate moral hazard when transacting is to have reputation involved. And in a token economy, we talk about, so moral hazard is where, you're doing something because someone else is paying for it. So you don't really consider so much. But if you add something else to consider, maybe you add reputation. Now I've got skin in the game in a different way. And I would want to reduce my bad actions because there's reputation in place. So this works especially well when we talk about multiple gameplay and interaction. So imagine if I'm just going to meet you and it's one-off. I don't really care what vibes I give you or what kind of information I give you because we're only going to interact once and then we'll both say goodbye and go to the other side of the world. But if you and I have to meet constantly, have to work together, have to interact with each other, then I want to be very sure that the information I give you is correct, because if I lie to you in the first round, maybe you lie to me in the next round, or you don't want to work with me anymore. So that I don't want that to happen. So I have a reputation to upkeep, and it's because it helps me in the long run. It's not just a short-term consideration. It's a long-term consideration when we talk about, sustainability of us working together. Another way to look at reputation is staking, and staking is one way we can add a monetary value to reputation. So a simple example will be TCRs, like token curated registries. And what they do is, as I mentioned before, you get to, instead of you having reputation, because we have, people like to be anonymous, right? And instead of me having reputation to my name, I have a reputation to my vote, to my stake. I'm staking my choice. So in TCRs, it's a decentralized list of options. Instead of staking with my name, I will stake with my choice with some tokens. So that's reputation in a way. And a lot of people are dealing with identity on blockchain. So that's something that you can probably consider to add in reputation. And the most extreme dystopian way is to look at the social credit score that is working in China, where reputation is not just based on this kind of interaction, just monetary interaction with people, but it looks at all the activities you do. So how good you are as a validator, how quick you validate things, where do you spend your tokens, where has your token been to and been transacted and been used. You can add reputation scores to that. And to maybe an extreme extent, maybe you can look at, based on, instead of giving identity or reputation to people, you can give reputation or identity to the tokens. So you can whitelist tokens based on the reputation they have been, based on the transactions they've been to, based on the hands of individuals they've been to, and translating that reputation into how it affects the ecosystem. So that maybe by having a whitelisted token, because this token has been to clean and verified wallets and has been used to vote 10 times. So whoever that has this token is very active in the space. And so this token represents a lot more than just a freshly minted token or a token that is just being in a wallet for 2 years. And probably a perk would be something like, I can when I stake with this token, I can redeem the stake quicker. Or I can, if I have to make transactions with this token, I can pay lesser gas fees because this token will be prioritized in a weighted average. So how tokens will be ranked for transactions will be both on transaction fees as well as if it's whitelisted. So then it helps with the allocation part, because then, instead of allocating resources based on the individuals, you're allocating resources based on the tokens, or how you're going to allocate almost like rights to the tokens, and what kind of rights do they get. So that's reputation in a different way. Instead of to people, it's to the tokens itself. So that's reputation. Now we're going to talk about fair allocation. Another word for fair allocation is egalitarian mechanisms. And it's basically what we want to do is to make sure that the system is fair to everyone. Now, it's very simple to say that I just want a system to be fair, but to what extent, how do you define fair? It depends on your ecosystem. Someone could say traditional voting is fair because one person, one vote. The toilet cleaner can have the same amount of vote as the ex-president, so it's fair to everyone in the ecosystem. But at the same time, is it fair if me as a person that has been working so hard on this proposal and I have more skin in the, maybe I'm voting for something on climate change, and I'm a professor that has been researching on climate change for 20 years versus someone who doesn't care about climate change and is working in the petrol and oil and gas, and he doesn't care about climate. Now, is it fair for us to both have the same intensity of vote? Because I have more skin in the game, and I have more background knowledge, like real research background knowledge, to make a more accurate vote and with my intensity versus another person that doesn't really care so much. But if we have the same vote, is it fair? So this, how you define fair is it's difficult to explain, because it depends on your ecosystem. It depends on you as the designer, and it depends on how you define what fair is. So that's something that you want to, talk about with your foundation or whatever to understand what's fair. Then you can start making fair mechanisms. But at the end of the day, examples of fair mechanisms would be, your ecosystem is truly decentralized. Everyone has a fair chance to participate, or equal chance. And equal chance or equal power, same power. It could be something like minting new tokens. It could be validating blocks. It could be voting on proposals, and everyone has an equal chance. So these are examples on where fair mechanisms can come into play. However, these are some questions that you want to ask yourself. As what do you want everyone to have the exact same power? Because it's true that it's fair if everyone has the exact same power, but some people just have more information because of their background than someone else. Like a lawyer has more information about an issue when we are resolving something on TCRs. Maybe we're resolving an issue on which is the best pizza on a TCR, right? Because we're ranking. And people can come in to have a say and dispute the issue. Now, people can have power to dispute the issue, but do you want to give the same power to an Italian pizzeria that has been making pizzas for 20 years or 50 years versus a random person in Singapore, have never eaten pizza, doesn't even like Italian food, just likes to eat food from Singapore? Do you think it's fair to give them both equal power to resolve this issue on TCR on which pizza is the best in Milan? Is this something you want to ask? Because sure, we can create fair mechanisms, but we can also, instead of making one big fair mechanism, because I say systems are dynamic, you can have small clusters of different kind of authorities or different kind of boards or different kind of smaller systems where people have power over it, but they have power only over this ecosystem and not the other one. So in the issue of TCRs, maybe we have a list of best pizza in Milan versus best chicken rice in Singapore. And the Italian guy that has been making pizza for 50 years has a very big say in that dispute for TCR, and the Singaporean person that likes to eat chicken rice in Singapore has a bigger say in the chicken rice TCR that is available. So they can have similar powers, but in different kind of environments. That could be something. That's also how you can look at how do you decentralize fairness. Do you also want the bigger players like the whales to have this appropriate, disproportionate advantage over minority players? One solution, so usually the answer is no, and one solution is to give more powers to minorities or small players. So, you kind of even out their power. But, to what extent are you sure that minorities and the small players will make the right decision? Because maybe they don't have skin in the game. Maybe they're not invested because they're not invested in the project. They don't really care so much, or the outcome, that the decision they make are not going to be the most beneficial for the entire ecosystem. Whereas maybe big players have more skin in the game, they invest more, they have more to lose, so they be more thoughtful about voting. So, for every kind of fair system, there's always debates. There's always good and bad. And at the end of the day, how much do you want? How much fairness do you want? What kind of fairness you want to talk about? And how you define fairness. So these are just questions to ask and to get started when designing your fair ecosystem or fair mechanisms. So I want to show you how allocation mechanism could work in two different layers. It's like a cake. A cake has a two-layer cake, a two-tier cake. The first cake, the bottom one, is the code layer. And, I went too fast. Okay, the first one is code layer, and the top layer is the mechanism layer. So if you think about it, the code layer is kind of like your blockchain layer, or your stuff that is automated, and the mechanism layer is stuff, rules in the game that you can input. So the code layer depends more on cryptography. How do you make sure that your allocation mechanism is fair, is good, and you can do this with cryptography. And if you're interested in that, a good paper is called Egalitarian Proof of Work by CryptoNode. You can find that in the Token Economics resource list. I will link that in the comments below. So if you have not read that, you can check that out. It's over there. What they do is they look at the different consensus mechanisms. You've got proof of work, proof of stake, delegated proof of work, and looking at them, they have a formula for it, like an egalitarian formula, like depending how. So fairness is it's difficult to define what fair is. So they use math to define what fair is, and from there they put a number to fairness and they rank them. So the outcome of this paper is saying that proof of stake is fairer than proof of work, and it's more egalitarian. This looks at a lot of different variables. Of course, you can argue that proof of work is fair because proof of work means that you don't need to have any tokens. All you have to do is to buy the hardware, like the ASICs or the GPU, and you can just start mining. But at the same time, is it fair? Because if someone lives in a country that electricity is cheaper, or if someone just has more money to be buying better ASICs and better GPUs to be validating transactions, then that's not very fair to someone else who doesn't have money. So it's not very fair. Proof of stake, you can also say it's fair. It's not fair because it's fair because everyone has an equal chance. You stake your tokens, and then equal chance of being picked. So you don't have the issue of buying hardware or electricity cost. But it's also not fair maybe because if you are a bigger player, you have a lot of tokens, you can stake more, so the probability of you getting being picked as a validator is also higher. So it really depends on how you want to argue. This uses a mathematical formula. If you're interested, you can read it. The mechanism layer, the top layer of the cake, looks at how mechanism is being designed. So how do you allocate transaction fees? How do you allocate power? How do you allocate validator role? So a quick case study would be in the bottom layer, the code layer, we look at Litecoin. So Litecoin uses script, SCRYPT, in the code layer. So what its script is to lower the advantage miners can get by switching GPUs, rates, or custom design mining systems. So as I mentioned, because let's say I'm like super rich and I can go to a factory and say that I want you to design the best GPU rigs, and this is the kind of mining systems that I want to specify so that I can be the best miner and the fastest miner, and I can be mining all the Bitcoin transactions. Now, that is an actual risk, or I can build like a big mining farm with all the best GPU rigs. So that now I have a greater chance of being a miner in proof of work. But what Litecoin does is it includes script, SCRYPT, and this is a code to reduce this kind of advantage. So you want to level out the playing field, you make it a little bit more fair, because then how you allocate which is the miner or which is the validator, it's a little bit more fair when you have this in place. But that's not what we're going to talk about. I want to talk more about the mechanism layer, and we look at Algorand. In Algorand, they use a simple mechanism, which is independent lottery, to pick the validators. So everyone, you don't need to stake anything. As long as you're a validator, you're a participant in Algorand's ecosystem, you'll be participating in an independent lottery to be picked as a validator. So, which is fair, because independent means that the outcome of the other person it has no link with me being picked as a validator. The probability is no link. Okay, and so for every block to be validated, they will pick 4 different clusters of people independently, 4 clusters, like 4 groups of validators to validate this block, and in each group they will pick all these individual validators independently. So it's a lot of independent lottery and independent rounds. So the probability of a bad actor taking control of 2/3 of the decision making is very low. So we're allocating in this way. And that's allocation mechanisms.